Hello everyone, welcome to this video where we will talk about genetic algorithm developed in C code. So this video we will try to explain you the basic of genetic algorithm. Yeah, so let's see the plan for this video. So we will start by introduction. Then we will move to the section where we will talk about how the genetic algorithm works and the key term for this algorithm, and in which application that we can use this genetic algorithm. Sorry, and yes, and also I will try to give you some key points why we use the genetic algorithm, and then we will finish by debugging and testing. So the genetic algorithm is a search and optimization technique inspired by the process of the nature selection. So the key concept for this algorithm is try to keep the fittest solution. So for example, so yeah, we will try to discover this in next slides. Then okay, so and this so it's so I will try to open a PDF file to explain you. So it's a report in the French language, but so this is the main how do you say, so this is the main component in the genetic algorithm. So it's composed of population, and inside the population there is a chromosome, and for each chromosome there is a gene. So for example, for a PID controller used in the to control some system like motors, something else, so there is multiple solution. So in order to find the best PID parameters, so you have to apply some functions to find some scores depending on the how do you want this system to respond. So for example, if you want your system to respond more quickly, or uh, you want the system to be more stable. So it depends on your specification. You have to develop a function, and for this function it calculates the score based on these three parameters. And for example, for this there is in population, and the chromosome it's one solution, so it means that there is the PI parameters and its score. And so the genetic algorithm will try to calculate this time by time till you find a score uh, that fits your specification. So for example, so let's continue the slides. So we will see how the genetic algorithm works. So there is initialization, where it starts to create some random solution, the population, and the selection step it's to choose the best candidate based on the fitness function. So this fitness function you can develop based on your requirements, speed of the system, stability, and more. And the crossover it's combining part of two solution to create a new one. So for example, there is a parent. So let's see. So we have initialization, evaluation, if the criteria is met or not. If it's met, so we can finish here. If not, we can do the selection. So we can select two parents of chromosome, and we do the crossover. Then we have to apply a mutation to modify some bits on those solution. So for example, for the crossover, so for example, we have parent number one, parent number two, and as you can see, there is number of bits, and here also there is the different set of bits. So for the crossover, at the position 4, 0, 1, 2, 3, it's 4, oh sorry, 1, 2, 3, 4. Then we can do the crossover between these two parents. So the parent P1 will take from this one, from sorry, so it will change the position, so it will keep this part and take the next part from P2, and this is the children number one. So as you can see, so it has the same first bits of parent 1, and then the complete is from parent number 2. The same for children 2. So this is a figure. It's clear. So we have this parent number 1, parent number 2, and after applying the crossover at the position, certain position, you can choose based on some function. Then we can do the crossover function. So it will change this certain bits on this position. And there is multiple. So this is uh, 1 point crossover, and there is also multiple points crossover. So you can, for example, this figure on this the middle, it's changing the bits between parent number 1, parent number 2. And the mutation, so for the mutation, it's like avoiding duplication. So for the mutation, it's make small change to introduce the diversity. So it's like to make sure that the solution are different, and the iteration repeats until the best solution is found. So for example, for this, in this figure, you can find that this algorithm runs, and at every steps check the criteria uh, are fulfilled or not. If are fulfilled, so we can finish the algorithm, else we can continue calculating the solution. And so this is how the genetic algorithm works. So the key term, as we mentioned before, there's a population group of candidate solution, chromosome representation of solutions. For example, for the PID control, there is KI, KP, KI, KD, and the score for each solution. And the fitness function is a measure of how good the solution is. And the operator, we have tree, selection, crossover, and mutation, as we saw previously. So for the application of this genetic algorithm, we have multiple application, and we have, for example, optimizing travel routes, tuning parameter machine learning, for example, for the PID control, scheduling and resource allocation, engineering design. So there is multiple field where we can apply this genetic algorithm based on our specification. So why we use the genetic algorithm? So advantage, handle complex and non-linear problems, work well with multiple objectives. So for example, you can develop many objective function to calculate some scores, and based on these scores you can choose the best solution for you, and doesn't require gradient information. Simple analogy, it's like guessing a password by evolving better guess over the time. So next, so we will introduce you an example of this code in C language. So we have some libraries. So in this example, we will create 20 population. So there is some variables. So mutation rates and crossover rates and selection rates. It's like it's the rate of mutation, because we will not perform the mutation, the crossover, and selection at every step. So there is some rate and to check if this fulfill or not. Then we can apply the mutation, for example. And the fitness threshold, so for example, if we will find a solution with higher than 80%, so we can select this solution. And the generation size, it's 400 solutions. So for example, in this, so we have 20 population, and for each population we have 400 chromosome. So in this case, we can find solution quickly. So for example, there is the target parameters. So for this solution, we will try to guess these parameters. So this is 10.25. So let's assume that this is the KP, KI, KD for the PID control. And we will try to use genetic algorithm to guess those parameters. So this is the some information, and this is the file for saving the logs. And we have offsprings, so it means that 16 children's new solution. So we will generate at each step 16 solution from the parents. And so this is a flag for the generation files. And we have also the struct. It has parameters. So we have three parameters to guess, and the fitness as we mentioned here. So we have three parameters and the score. So that's what I implement here. So three parameters: kp, ki, kd, for example. So if we want to guess the pid parameters, and we have the fitness. So we have multiple function, start genetic algorithm, crossover, and we have initialization of the pool of solution. So for example, the this this is called pool of solution. It contains multiple chromosomes or solutions. Then we have a selection function, fitness function, and this is to write a file. This is this slice this slice array is for crossover, so it can be used in the crossover function. And there is a mutation, generates a random number. This is for to check those rates if we have those, or if we fill these rates, we can apply these functions. And merge offsprings, for example, if we perform the crossover, we have to slice. After slicing, we have to merge offsprings into this pool of solution. And we have the fitness function. So for example, we have parent number one, parent number two, so and children number one, children number two. And the parameter of pools, it's the generation and the population. And we said before we have 20 generation and 200 population. So this is a function for each one. Then we will start genetic algorithm. So for this genetic algorithm we have, so you can see there is initialization, evaluation, selection, crossover, mutation. So this is the genetic algorithm. So this is crossover, mutation, fitness, and we save the solution to the file. So for the initialization, we create a random solution. So this is a random float, and we assign it for each generation. There is a population, and we create a solution for this. Then we have the fitness. So the fitness, it's like calculation. So the fitness, we will check the fitness to calculate the score from the population. And for the starting the evaluation, we will try to check if the solution is bigger than the score or not. So start evaluation process. Then we have the selection. So for the selection, we will check if the fitness of the function. So we will try to check. In this case, I'm trying to, for example, I'm trying to compare the fitness of each solution and try to list it from the biggest fitness to lowest fitness to keep only the biggest. The solution has biggest or highest fitness in the first list, and then we save them in the first list, first index. And we after that we call the slice array, and for this slice array we have to slice the array. So for example, so there is the solution or population and the percentage. So if we have to apply this uh, slice or not, so we calculate the percentage, new size. So for example, if we want to slice, for example, 25 from this array, 50%. So instead of giving the index, we are giving the percentage of the slicing. Then we calculate the slice, and then for this we are trying to save only the first for example, first, because here we have percentage and population. It will give us a size, so we will try just to keep the from 0 to the new size solution. And then we have to perform this slice. So for the other solution, we will keep only -1, and for the solution from the new size to population, we will give them 0, and stay else we will give -1. And so this is the slice. So this is to complete the slicing of the solution, and here we can perform the crossover. So for the crossover, we're giving the crossover weight. So this is checking the new size. So for example, we have parent number 1, parent number 2, and we have to slice the function. So this is only for debug function, and this is for saving the function. So this is the slice function. I think it's big topic to explain everything in one video, so maybe I will try to make for each video I will try to make a video to explain each function, because it's taking time. So I will just try to show you the final result for this. In the future, I will try to upload a video for each function and try to implement it from scratch to understand more. So I will try to compile this. So it's compiled. The GA G8 is. So this is trying to find a solution. So it's taking some time to find the better solution. So till now, as you can see, it's the score is below than 80, so it will keep trying to find the solution until one of the solution is above, or its score above 80%. So yeah, let's wait, check if we could find the solution. So maybe next time we can try to modify the crossover or the mutation rates in order to find the solution as quickly as possible. Because so I didn't yet tune any parameters, so I just choose random parameters. So that's why it's taking too much time. But maybe if we do some tuning, we can find a solution. So for example, so this is the best fitness, it's 87, and for the solution it's, as we mentioned, that we are trying to try the function or trying to list the best parameters in the first list or first index. So for example, for this generation, so yeah, so this is 9. So let's see. So our targets were our targets parameter were these parameters. So yeah, it was 10, 25, 544, 722. But you can see they are close enough, but because the fitness it should be more than 90%, 95 in order to be close to these parameters. But as you can see, it's too close for these parameters. So it's only, yeah, so for example, it's 9, it's close to 10. Also the 5, it's really 5, but yeah, so the solution are too close. And we have the txt file, we save all the solution. So for example, today it's 31, So we create a report for this solution, some global variables, and we have the generation number one. So you can see the solution were different from the targets. So you can see 25, 4 to 27. It's something different, but with time, it's becoming too close to the solution, or it's like converting to the solution. So yeah. So if you need to make more videos on the function, please comment below and try to subscribe and like the videos in order to, yeah, this will make me motivated to create the videos to explain more about this function for the solution. And also I will try to implement this in real time for the STM32 to, for example, to tune the PID parameters for the motors in order to control four motors, for example, in drones or in quadcopters, or even for bicycle, something to control everything. You need to tune the parameters. So if you want this, please let me know in the comment section. Yeah, thank you for watching this video. See you soon.